Assalamu alaikum. My name is Muhammad Akmal, and the topic for today's presentation is plasma arc cutting. So let's start it with a introduction. So plasma arc cutting is also known as plasma fusion cutting, and we will begin the topic with its definition. As we know that plasma arc cutting or plasma fusion cutting is a fabricated process which employs superheated ionized gas funneled through a plasma torch to heat, melt, and ultimately cut electrically conductive material into custom shapes and designs. So now we will briefly explain the process of it in the introduction section. So plasma cutting is a process that is used to cut steel and other materials. First of all, a net gas is blown there, which is blown at a high speed. After that, electrical arc is produced. After that, electrical arc is produced there. At the same time, electrical arc is produced through the gas from the nozzle to the surface being cut, turning some of that gas to plasma. The plasma is sufficiently hot to melt the metal being cut and move sufficiently fast to blow molten metal away from the cut. Uh, after that, after introduction, we will continue our presentation with our plasma arc cutting tool, and we know that plasma arc cutting tool is also known as plasma gun, plasma cutter, or plasmatron. It is actually a device for generating a directed flow of plasma. So let's begin with its process. Actually, the plasma arc cutting tools or plasma cutters works by sending an electrical arc through the gas that is passing through a constructed opening. The gas can be sharp air, nitrogen, argon, oxygen, etc. We can also use other gases also. This elevates the temperature of the gas to a fourth state. We all know that the fourth state is plasma. After that, After that, the electrical conductivity of the plasma causes the arc to transfer it to the work. The restricted opening, or we also call it as nozzle, the gas passes through causes it to squeeze by it at a high speed, like air passing through a venturi in a carburetor. The high-speed gas cuts through the molten metal. The gas is also directed around the perimeter of the cutting area to shield the cut. This is the diagram which shows that how the process works. We can see that in here, the plasma gas, in yellow area there is a plasma gas. The electrode provides an electrical arc, and through gas we produces an electrical arc. Here the source supply is also there, the electrode is there, cooling water is there to support the gas, and after that the metal is being cut and rose is under it. So our next slide is about the machine parts and their functionality. For the plasma arc cutting process, we use plasma cutting equipment. Plasma cutting machines vary from model to model and applications with setup, ranging from simple handheld torch attached with a power source to the complex ones that are programmable and automated CNC machines. The basic equipment setup for these plasma cutting machines includes power source, arc starting console, gases and media employed, torque assembly, cooling system, work, and finally the workpiece we produce. So let's start here with the power source. The power source provides the energy to initiate the pilot arc and maintain the main arc throughout the plasma arc cutting process. They typically have high non-load voltages. After that, we will begin the arc standing console, which is also known as ACS. The ACS produces the initial spark which initiates the pilot arc circuit. Gases and media employed. Plasma gases are categorized into ignition gases, cutting gases, and secondary gases. Gases employed can be an inert, reactive, or a mixture of two previous gases. Water is also employed as a secondary medium during the cutting process, which is as I show you in the previous diagram that it shows as a cooling material. After that, the torque assembly includes the electrode and nozzle that is connected to the power supply and utilizes the plasma and cutting gases to initiate and perform the plasma cutting operation. Cooling system. The cooling system cools the torque assembly components and workpiece, extending the lifespan of the consumables. After that, in the end, we will talk about the workpiece. The workpiece is a material being cut. The material must be electrically conductive to the plasma cut, as the workpiece serves as a component of the main arc. So now we will talk about working principle, and then we will talk about the methods to start the arc. So first of all, let's talk about working principle. As working principle consists of the following steps, which are pilot arc initiation, main arc generation, localized heating and melting, material ejection, and arc movement. So let's start it with the material ejection. Material arc initiation. So we know that plasma cutting processes involves creating an electrical channel of superheated electrically ionized plasma from the cutter itself through the power of the workpiece to be cut, thus forming a completed electrical circuit back to the plasma cutter. This is accomplished by a compressive gas which is blown through a focused nozzle at high speed towards the workpiece. Then we will talk about the main arc generation. Then an electrical arc is then formed within the gas between an electrode and near or integrated into the gas nozzle and workpiece itself. The electrical arc ionizes some of the gases here, thereby creating an electrically conductive channel of plasma. The arcs are generated in a three-step process. A high-voltage spark briefly ionizes the air within the torque head. This makes the air conductive and allows the pilot arc to form. The pilot arc forms within the torque head with current flowing from the electrode to the nozzle inside the torque head. The pilot arc burns up the nozzle, a consumable part, while in this phase the air then blows the plasma out of the nozzle towards the work, providing a current path from the electrode to the work. When the control system senses current from the electrode to the work, it cuts the electrical connection to the nozzle. A current then flows from the electrode to the work and arc forms outside the nozzle. Cutting can proceed without burning the nozzle. Nozzle life is limited by number of arc starts, not cutting time. After that, we will talk about the methods that we use to start the arc. Plasma cutters are used as a number of methods to start the arc. In some genres, the arc is created by putting the torque in contact with the workpiece. Some cutters use a high voltage, high frequency circuit to start the arc. A third, less common method is a captivative discharge into the primary circuit via a silicon controlled rectifier. So in this diagram again we can see that it is a electrode. We can provide the plasma power supply to it. There's a compressed gas coming from the above. Torque is in the left side as shown in diagram, and nozzle from which the spark is producing and is cutting the workpiece. So now we will talk about the materials that we can machine. Plasma cutting is an effective way of cutting thin and thick materials alike. First of all, we'll talk about the handheld torches. These handheld torches can usually cut up to 38 millimeter or 1.5 inch thick steel plate. Then we will talk about stronger computer control torches that can cut up to 150 millimeter or 6 inches thick. Then let's talk about the materials that can be machined electrically conductive and efficient. Materials are lowered steel, stainless steel, aluminum, brass, and copper, although other conductive materials may be cut as well. So and there are also some materials that we can't use, such as plastic and wood, as they are not electrically conductive and cannot be plasma cut. So now talk about the benefits of this as compared to the other machines. The first and foremost benefit is that we can use these plasma torches at a very cheap rate, and also they are widespread use from a large scale industrial CNC applications, and we can use the cutting of we can use it in a cutting of all electrically conductive materials. Also we can also use them to cut the high alloy steel and aluminum materials in medium and large thickness, and they can give excellent performance in small and medium mild steel thickness. We can also use them to cut the high strength constructional steel with low heat input. We can also use them to cut granted automation, and they give us high cutting speeds which are 10 times higher than oxyfuels, and plasma cutting also guarantees us automation. And in the end, we will talk about the latest technologies that uses plasma arc. So in the recent years, there have been many more developments in plasma arcs. Traditionally, as we know that the machines we use for the cutting arcs are horizontal, but in the latest technologies that we are using is that we are using vertical CNC plasma cutting machines. There are many benefits of that, and they are and which means that we can provide a smaller footprint. We can increase the flexibility of our product. We can optimize our safety, and the foremost is that first and the most important thing here is that it can provide us a faster operation. We know that in the past decades, plasma torque manufacturers have engineered new models with a smaller nose and thicker plasma arc, which is very important for us. This allows near laser precision on plasma cut edges, which are not being done in the previous decade. Several manufacturers have combined precision CNC control with these torques to allow fabricators to produce parts that require little or no finishing, which is very important for us. This is our presentation, and thank you so much.